Hi, thank you for taking my C# Basics course. Let me quickly give you an overview of what you're going to learn and how I've structured this course. In the first section, I'm going to talk about fundamentals of C# and .NET. One of the questions that a lot of beginners ask is, what is the difference between C# and .NET? So I'm going to cover that. I'm also going to talk about CLR, assemblies, namespaces, IL code, and stuff like that. Then over the next two sections, I'm going to talk about types. I'm going to talk about primitive and non-primitive types. Now at this point, you still cannot write any C# programs, but I have designed a number of quizzes to help you reinforce what you're going to learn. Then from section 4, where I talk about control flow, you're going to start writing simple C# programs. And from that section onwards, in every section, you're going to learn something new about C# and you're going to write more interesting programs. And finally, I'm going to conclude this course with a section on debugging. So I'm going to show you some of the tools we have, so when you have bugs in your code, you know how to find them and get rid of them. I'm also going to talk about some good programming practices that help you write better and more reliable code. So we have a lot to cover, and let's get started. Okay, so this is the very first section of this course. In this section, I'm going to start by teaching you the very basics of C#. One of the questions that a lot of beginners ask is, what is the difference between C# and .NET? So that's the first thing I'm going to answer here. Next, I'm going to talk about CLR, or Common Language Runtime, which is the runtime environment for .NET applications. Next, I'm going to talk about the architecture of .NET applications. And as part of this, I'm going to introduce you to concepts such as classes, namespaces, and assemblies. And finally, I will show you all these concepts in action. I'm going to introduce you to the very basics of Visual Studio and write a very simple C# application so you can see classes, namespaces, and methods in action. I hope you enjoyed this section, and let's get started. Okay, what is .NET Framework and how is it different from C#? Some developers who are absolutely new to C# don't know the difference, so in this lecture I'm going to talk a little bit about C# and .NET Framework. C# is a programming language. .NET is a framework for building applications on the Windows. .NET Framework is not limited to C#. There are different languages that can target .NET Framework and build applications using that framework. Examples are F# or VB.NET. Okay, now, but what exactly is .NET Framework? .NET Framework consists of two components. One is called CLR, or Common Language Runtime, and the other is a class library for building applications. In the next lecture, we'll talk about CLR in more detail. Okay, before we understand what CLR is and why we need it, let me explain a little bit about the history of C#. Before C#, we had two languages in the C family, the C language and C++. With either of these languages, when we compiled our application, the compiler translated our code into the native code for the machine on which it was running. Which means if I wrote an application in C++ on a Windows machine with 8086 processor architecture, the compiler would translate my code into the native code for that machine. That is a Windows machine with an 8086 processor. Now we know we have different hardwares and we have different operating systems. So if I took that application, that compiled application, on a computer with a different architecture, that would not run. So when Microsoft was designing the C# language and the .NET framework, they came up with an idea that they borrowed from the Java community. In Java, when you compile your code, it's not translated directly into the machine code. It's translated into an intermediate language called bytecode. And we have the exact same concept in C#. So when you compile your C# code, the result is what we call IL, or intermediate language code. It's independent of the computer on which it's running. Now, we need something that would translate that IL code into the native code for the machine that is running the application. And that is the job of CLR, or Common Language Runtime. So CLR is essentially an application that is sitting in the memory whose job is to translate the IL code into the machine code. And this process is called just-in-time compilation, or JIT. So with this architecture, you can write an application in C# And you don't have to worry about compiling that into the native code for different machines. As long as a machine has CLR, that can run your application. Okay, now let's learn about the architecture of .NET applications. At a very high level, when you build an application with C#, your application consists of building blocks called classes. These classes collaborate with each other at runtime, and as a result, the application provides some functionality. Now, what is a class? A class is a container that has some data, which is also called attributes, and functions, which is also called methods. Functions or methods have behavior. They execute code. They do things for us. Data represents the state of the application. Let me use an example. Think of a car. A car has some attributes, like its make, its model, its color. These are the attributes of a car. A car also has some functions. We can start it, or we can move it. So you can think of a car as a class. In a real-world application, we have tens, hundreds, or even thousands of classes, each class responsible for a piece of functionality. An example of that is classes that are responsible for getting the data from the user, process the data, and display something to the user. Now, as the number of classes in an application grows, we need a way to organize these classes. That's where we use a namespace. So a namespace is a container for related classes. For example, in .NET Framework, we have namespaces, each containing tens of related classes. We have namespaces for working with data, like databases. We also have namespaces for working with graphics and images. We have namespaces for working with security. Now, in a real-world application, as these namespaces grow, we need a different way of partitioning an application. And that's where we use an assembly. An assembly is a container for related namespaces. Physically, it's a file on the disk, which can either be an executable or a DLL, which stands for Dynamically Linked Library. So when you compile an application, the compiler builds one or more assemblies depending on how you partition your code. In the next lecture, we're going to write a very simple C# application, and you're going to see all these concepts in action. Okay, in this video, we're going to have a quick tour of Visual Studio and build a very simple C# application. So here I've got Visual Studio open. Let's go to File, New, Project. Okay, in this dialog, on the left side, we've got a section called Templates, and here you see the kind of applications we can build with C#. So as you see in the list, we can build desktop applications, web applications, apps for cloud, mobile, services, workflows, and various kind of things. But in this course and the subsequent parts of this course, we're just going to focus on console applications. A console application is a very simple application that does not have a graphical user interface. And it's a great learning tool for learning a new language. So we are not going to be distracted by various complexities of larger applications. So on the left side, select Windows, and on the right side, select Console Application. Then give a name to your project. So let's call it Hello World, which is a common tradition when learning a new language. And specify a location. You can put it wherever you want. And know this concept of solution. In Visual Studio, we have this concept of solution, which can have one or more projects. With a very simple application, you have only one solution and one project. But as your application grows, you add more projects, each responsible for something different. For now, we don't have to worry about it. Now click OK. All right, let's see what's happening here. Some developers get a little bit intimidated the first time they open Visual Studio. And that's fair enough because there's so many menus and panels here that is a bit confusing. But let me tell you something. 90% of the time, you're going to use only 10% of these or even less. So don't worry about all these menus here. You don't need to use all of them at all times. 90% of the time, all you need is the code editor here. And sometimes you need the Solution Explorer. In fact, I personally hardly ever use Solution Explorer. because I do everything with my keyboard. And if you watch my course, Double Your Coding Speed, you will see that everything is possible with keyboard. So you don't need these panels here. You don't need to grab your mouse and navigate around. You don't really need this stuff. Also, none of the stuff on the toolbar are ever required. Don't worry about it. Everything you can do with your keyboard. All right, now let's take a look at this first C# program. So we created a console application, and on the right side, you see the Solution Explorer panel. In case you don't see that, go to View and select Solution Explorer. So at the top, you see we have a solution, which has only one project. Under that, we've got the project called Hello World. Look at these 4 items here. Properties, expand that. We have a file here called assembly info. This is the identification for the assembly that will be produced as a result of compiling this application. So when we compile a console application, we're going to get an executable, and that's an assembly. That assembly has an identification. Look at these attributes here, like the title, description, which is currently not set, company, product, copyright, trademark, culture, a GUID, various kind of things, like even version. So these are all part of assembly identification or assembly manifest. In most cases, you don't have to worry about it. But if you want to create an assembly and you want to distribute it, send it to other people, then you may want to come here and give it a proper name and a proper version. So for now, we don't have to worry about it. Under references, you see any assemblies that this project is referencing to do its job. When you create a project with Visual Studio, by default, it adds a reference to a bunch of assemblies that you see here. These are all part of .NET Framework. So at a minimum, Visual Studio assumes you're going to use classes in system assembly or system.data to work with databases and so on. You may not necessarily use all these assemblies in your project, but that's just part of the template. App.config is an XML where we store the configuration for this application. Sometimes you may want to store connection strings to the database, or you may want to have some settings about your application. All of them will end up here. And finally, you see program.cs, which is where we're going to start writing code. All right, let's see what's happening here. So in this file, program.cs, on the top you see a bunch of using statements. What is this all about? Well, our project is called Hello World. So by default, Visual Studio creates a namespace called Hello World. When we write code in this namespace, we have access to any classes defined in this namespace. So if we want to use a class that is defined in a different namespace, we need to import it in our code file. And that's why we use the using statement. So by default, Visual Studio has these 5 using statements. System is a namespace in .NET Framework. And that's where we have all these basic utility classes and primitive types there. System.collections.generic is used to work with lists, collections, and so on. System.link is used to work with data, and it's a comprehensive topic that I have covered in my C# Advanced course. System.text is used to work with text, encoding, and stuff like that. And finally, system.threading is used to build multi-threaded applications. In this video, we're going to create a very simple application, and we're not going to use any of these 4 namespaces here. So we're just going to use system. For now, I leave them there, and then I will show you how to clean them up. All right, so here's our namespace. And inside namespace, by default, we have a class called program. So every console application you create with Visual Studio has a class called program. Inside program, by default, we have a method or a function called main. And that's the entry point to the application. So when you run your application, CLR executes the code inside main method. And that's where everything kicks off. This method is declared as static, and that's something I'm going to cover later in the next section. Methods have input and output. So what goes inside parentheses is the input to the method, which we call parameter or argument. Note that parameters are optional, but in this case, in the default template, the main method has a parameter called args, which is of type string array. We're going to learn about string array in the next section. What you see before the method name is the return type or the output of the method. Void in C# means nothing. That means this method does not return any value. It just contains some code. That's it. Also, note that C# is a case-sensitive language. So this main has to be with capital M. Otherwise, CLR is not going to find this method as the entry point of the application. Okay, and one last thing is note these curly braces. So wherever we have a block of code, we need to surround it with curly braces. So that is applicable for methods, for classes, and for namespaces. All right, now let's write a very simple C# program. So let's go here. We have a class called console, which is used to read data from console or write data to it. It has a bunch of methods. We can access these methods using the dot notation. And here you see various members of this class. Methods are indicated by a purple cube. So beep is used to play a beep sound, or clear is used to clear the console. We're going to use the writeLine method. This method can optionally take a parameter. So I'm going to pass a string here. Hello world. Just that. And note that statements in C# terminate with a semicolon, as you see here. Now take a look at using system on the top. Do you see that it's highlighted, whereas the others are grayed out? The reason for that is, in this file, we're using a class called console, which is defined in the system namespace. That's why that using statement is active. We are not using any classes defined in other namespaces, and that's why they're grayed out. So we can get rid of them to make our code cleaner. We can either delete each one by Ctrl X, like that. Or if you're using ReSharper, you can get rid of all of them by pressing Alt and Enter here and selecting the first option, which is Remove Unused Directives in File. So it's faster. Now let's run the application with Ctrl and F5. So this window that you see here, this black window, is what we call console. And that's why this kind of project is called console application. Okay, that's it for this lecture. From this point, in every lecture, we're going to learn something new about C# and we can write more interesting and more complex programs. I hope you enjoyed this lecture and thank you for watching. Well, hello. It's Mosh here, your C# instructor. I just wanted to quickly let you know that this video you've been watching is actually part of my C# Basics course on Udemy. In this course, I walk you through all the core concepts of C# in a step-by-step fashion. Plus, you get access to exercises, cheat sheets, and a discussion board to ask your questions. In case you're interested, you can get this course with a discount using the link in the video description. And if not, that's perfectly fine. Continue watching as the next section is coming up. Okay, this section is going to be the first step in your journey to learn C#. So I'm going to introduce you to variables and constants. I'm going to talk about various data types and type conversion. I'm going to talk about scope and overflowing. And finally, I'm going to talk about various operators we have in C#. So let's get started. Okay, we're going to start our journey by learning about variables and constants. Let's start by two definitions. A variable is a name that we give to a storage location in memory, where we can store a value. And a constant is an immutable value. That is a value that we know at compile time, and that value cannot change throughout the life of the application. Why do we use constants? The reason for that is to create safety in our application. Imagine you're creating an application that involves some mathematical computation around circles. We have this number called p, which is 3.14, and we use that to calculate the area of a circle. That number should always be the same. We don't want to accidentally change that in our program. If we accidentally change that, everything is going to blow up in terms of the results the program produces. So we declare that number as a constant. And this way we create safety in our application. In C#, to declare a variable, we start with a type, followed by an identifier, and finally, semicolon. Here, int represents integer, which is a number between -2 billion and +2 billion. Later in this video, I will show you all the primitive types that you need to know. Also, note that C# is a case-sensitive language, which means in this case, these two identifiers are different. One has lowercase n and one has uppercase n. When declaring a variable, we can optionally assign it a value, like what you see here. You don't have to, but there is one thing you need to know about variables, and that is you cannot use a variable unless you initialize it. So let's say if I declare this int number here and I decide to display it on the console, my application will not be compiled. I have to assign it a value before I can use it, before I can read it. I will show you that later when we jump to coding. To declare a constant, we start with the keyword const. Next, we have the data type and an identifier, and here we have to initialize it with some value. We cannot define a constant without setting its value. There are a few things you need to know about identifiers. First one is that an identifier cannot start with a number. So you cannot have an identifier like the one you see here. Instead, you need to replace 1 with the word 1. Also, an identifier cannot include whitespace. So you cannot have an identifier like first space name. It has to be one word. An identifier cannot be a reserved keyword, like int that you saw earlier. If you're desperate to use a word that coincidentally clashes with one of the C# keywords, you can prefix that with the @ sign. And finally, as a recommendation, always use meaningful names. For example, avoid a name like FN. Instead, use first name. This way, your code will be more readable, more maintainable, and cleaner, and everybody will understand that. In terms of naming convention, here are 3 popular naming conventions that have been around in the C language family. We've got camel case, Pascal case, and Hungarian notation. With camel case, as you see I have bolded here, the first letter of the first word is lowercase, and the first letter of every word after has to be uppercase. With Pascal case, the first letter of every word has to be uppercase. With Hungarian notation, we prefix the name of a variable with the data type it uses. So here str represents a string. Hungarian notation is not used in C#, and I have noticed programmers coming from C or C++ background use that in their code. If you're one of them, I highly recommend you not to use Hungarian notation because C# developers are not used to that and they don't like to see Hungarian notation in the code. It makes your code look a little bit ugly. So in C#, to name your local variables, use camel case. So as you see here, the first letter of the first word is lowercase, and if we had more words here in the identifier, the first letter of every word had to be uppercase. For constants, use Pascal case. So here you see I've got a constant here, constant integer, and the first letter of every word is uppercase. Here is the list of most commonly used primitive types in C#. In fact, the actual list is slightly bigger than this, but I deliberately decided not to include those data types because they're hardly ever used. In fact, they are there for interoperability with other languages. I personally, over the past 12 years of me coding in C#, I've hardly ever used them. In fact, never. So I decided not to confuse you with too much details that you don't need. In the next slide, I've got a link here in case you want to learn about the other primitive types. So let's take a look at the table here. On the left side, I have divided these data types into 4 categories: integral numbers, real numbers, character, and Boolean. This column shows the C# data types, and these are C# keywords. Note that C# keywords are always lowercase. Each of these C# keywords or C# types maps to a type in .NET Framework, which is displayed in this column. So these types are part of the .NET Framework. And when you compile your application, the compiler internally would translate the C# keyword you use here to equivalent .NET type. The third column here shows the number of bytes each data type uses, and I have listed these data types from the smallest to the largest in each category. So in the category of integral numbers, you see byte is the smallest, it takes only 1 byte, whereas long is the largest and it takes 8 bytes. The more bytes we have, the more storage we have, and we can store larger numbers. You don't really have to memorize the range of each data type, but remember, byte can store a value between 0 to 255, Short can store a value between minus 32,000 to plus 32,000. Integer can store a value between minus 2 billion to plus 2 billion, and long is even bigger than that. In terms of real numbers, we have three data types: float, double, and decimal. Float maps to the single type in .NET Framework, and it takes 4 bytes. And as you see, it can store a very large number. Double is twice as big, so it uses 8 bytes. And decimal uses 16 bytes. The more precision you need, the bigger data type you use. We also have character, which is represented by char keyword, and it's 2 bytes. So characters in C# are Unicode. And finally, we have bool, which represents Boolean, which can be either true or false. In case you want to learn more about the other data types that I told you they're not really used, you can simply go to Google and search for C# built-in types, and the first page is the MSTN page that lists all the primitive types in C#. Most of these data types are pretty straightforward, but there is something tricky about real numbers. In this table, I have listed the data types we have for real numbers: float, double, and decimal. I've highlighted double because that's the default data type used by its C# compiler when you're using real numbers. So if you want to declare a float, you need to explicitly tell the compiler to treat the number you have as a float. Here's an example. I've declared a float, call it number, assign it 1.2. Here I have added the suffix f, and that is to tell the compiler to treat this number as a float. If I didn't have this f here, compiler would think 1.2 is a double, because double is the default data type for real numbers. And of course, I cannot assign a double number into a float, so the program would not compile. Same applies to decimals. So if you want to declare a decimal, you need to add the suffix m at the end of the number. In C# we also have a few other types which are not considered primitive types, and they are string, array, enum, and class. We'll learn more about them throughout this course. Okay, that's it for this lecture. In the next lecture, we're going to talk about the concept of overflowing. I hope you enjoyed this lecture, and thank you for watching. Okay, now let's talk about the concept of overflowing. Here I've declared a variable of type byte, call it number, and assign it to 255. As I told you earlier in the slides, 255 is the largest value you can store in a byte. Now in the next line, I'm increasing the value of number by 1 and trying to store 256 in the number. But if you compile the application and display number on the console, you will see 0. And this is what we call overflowing. So we have exceeded the boundary of the byte data type. In C#, by default, we don't have overflow checking, which means we can modify the value of a variable at runtime, and if we go beyond the boundary of its underlying data type, we will get overflow. Now, sometimes this is not desirable in your application. You want to stop overflowing. If that's the case, you need to use the checked keyword. So here is how it works. We have the checked keyword, followed by curly braces, which indicate a code block. And inside that block, we have the variable declaration and any kind of arithmetic operations. With this code, overflow will not happen at runtime. Instead, an exception will be thrown, and the program will crash unless you handle the exception. The topic of exceptions is an advanced topic, and I have covered it in my C# Advanced course. For now, all I want you to know is that if you use the checked keyword, overflow will not happen, and instead, the program will throw an exception. Now, do we really need that in reality? Honestly, I have never ever came across this situation. Because if I was concerned that in this case my number variable would overflow, I would just simply use the short data type instead of byte. But I decided to include the concept of overflowing because I wanted my C# course to be comprehensive. So just be aware of that in case you hear about overflowing somewhere, but you're probably not going to use that in the real world. In the next lecture, we're going to talk about the concept of scope. Okay, let's talk about the concept of scope. What is a scope? Scope is where a variable or a constant has meaning and is accessible. Take a look at this block of code here. As you know, a block is indicated by curly braces. Here we have 3 blocks of code. Here's one, here's another, and here's the last one. Inside the first block, I've got a variable called a. And a is accessible anywhere inside this block or any of its child blocks. If I go out of this block and try to access a, the program will not compile. The same rule applies to other variables. So let's take a look at this block here. B is meaningful anywhere inside this block or any of its children. If I go outside this block and try to access B, I'm going to get a compile time error. Okay, I think that's enough theory for now. Let's open up Visual Studio and do some coding. Okay, let's start by declaring a variable of type byte and call it number. Now we want to display it on the console. So as you remember from the last lecture, we type console.writeLine and put the variable here. Note that as I was typing console.writeLine, my ReSharper plugin automatically added this using statement on the top. System is a namespace, and console is a class that is defined in the system namespace. So in order to use the console class, we need that declaration here on the top. If you're not using ReSharper, you have to go here and manually type using system semicolon. Okay, now take a look at this number here. It has a red underline. And if we put the mouse cursor here, it says local variable number might not be initialized before accessing. If you remember from the slides, I told you in C#, before you can access a variable, you need to set it. You need to initialize it. And that's the reason here we have the red underline. We cannot display the number on the console before initializing that. So if I try to compile the application, we're going to get an error. To compile an application, you press Ctrl, Shift, and B. And here is the error list. Use of unassigned local variable number. We can solve this problem by initializing number, like setting it to 2, for example. And you see the red underline is gone. We can compile again, Ctrl, Shift, B. Build succeeded, take a look here. Okay, now we can run the application by pressing Ctrl and F5. Okay, so we got 2 on the console. Now let's extend this example and declare a few more variables. We can define an integer, int count equals 10, and a float, say total price equals $20.95. Now note this red underline here. Let's find out what's happening here. So I put the mouse cursor here. It says cannot convert source type double to target type float. If you remember from the slides, I told you by default the C# compiler treats real numbers like this one here as double, whereas we are declaring a float. So here we need to explicitly tell the C# compiler to treat this real number as a float, and we can do that by appending an F at the end. So the error is gone. Let's declare character. So char character equals A. Note that in C# we enclose characters by single quote, like here. We can also declare a string. String is not one of the primitive types, and I have covered it in a separate lecture in this course. But for now, let me show you how to declare a string. We just type string, give it a name, first name equals Mosh. Note that with strings, we enclose them in double quote. So that's one of the differences between strings and characters. And finally, let's declare a bool. Bool is working equals true. So with bools, we can either set them to true or false. Both true and false are keywords. As you can see, they're indicated by the blue color here, and they're lowercase. So everything you see here that is blue is a keyword, like static, void, string, class, namespace, and all these data types here. Now let's display these variables on the console. So let me show you a trick. Instead of writing console.writeLine, we can do a shortcut. This is what we call a code snippet. So we type CW, that is short for console, writeLine, and then press tab. And Visual Studio automatically converts that to console.writeLine. There are various code snippets that help you write code faster. and I will try to point them out throughout this course. So let's display count. Now another one, total price, and note that I can just type TO, and here's what we call IntelliSense. It's Visual Studio's auto-completion mechanism. You don't have to type the full name of a type or a variable. As long as the IntelliSense detects that and is highlighted here like total price, you can simply press tab, and there you go. Visual Studio automatically completes that for us. Let's display the character. Same here, I just press tab. Again, I typed only a few characters. You can press tab or enter. And finally, it is working. We run the application by Control and F5. So we got all these values on the console. Okay, now let me show you something else. In C#, we have a keyword called var, which makes variable declarations easier. For example, here, instead of explicitly specifying the data type for each of these here, I can simply type var. And I let the C# compiler detect the data type for this variable here. So let me replace all of this with var. Okay, now if we hover the mouse over the var keyword, we can see the underlying data type. In this case, it's system.boolean, which is the .NET type, which maps to C# bool keyword. How about this one? That's a string. And this one is a character. And this one is system.single, which maps to float in C#. And in the case of count, it's int32, which is integer. And same for number. So the tricky thing here is, by default, C# treats integral numbers as integer. And when you use the var keyword, it assumes that it's an integer. If you really want to go for a byte, then you have to explicitly specify it as byte here. But telling you from experience, it's safe to use integer in most cases. In fact, if you look at the classes in the .NET framework, in most cases, integer is the data type used for representing integral numbers. Okay, I revert this back. Now I show you something else. So let's take a look at this one here. So it's a char, which is a character. We can put the mouse cursor here and press Control and then click. That opens the Object Browser window. Take a look here, it's Object Browser. And it's a way to look at the various classes in your project or in the .NET framework. In this case, because I did a control click on the char or var keyword, this is what we got here. So char is highlighted in the Object Browser. On the right side, you see all the members of the char type. So these purple ones are functions or methods. If you scroll down here, you see two fields here, min value and max value. We'll explore them shortly. And note that here is the declaration of char. Char is a structure. We will cover structures later in this course. And note that it's a member of system namespace. You can click system, and that shows the system namespace as well as all the types defined in the system namespace. So these are part of the .NET framework. Okay, let's close this for now. Let's explore another example. So I'm going to get rid of all the code here. We can simply press Ctrl X on each line. And that deletes all these lines here. Okay, let's do a console.write line. So CW, tab. This time I pass a string here. And I specify two placeholders. And finally, supply a couple of arguments. Okay, let's see what's going on here. So here, what we have is called a format string. It's a kind of string that can be used as some kind of template. So at runtime, what we have here, indicated by curly braces and 0 as the argument, will be replaced by the value we pass here. So 0 represents the first argument after this format string. And 1 represents the second argument after this format string, in this case, byte.maxValue. So let's run this application. We got 0 and 255. And that's the range that you can store in a byte. We can do the same with a float. So CW, tab, a format string, float, main value, float, max value. Run the application. So this is the range we can store with a float. It's a huge number that is displayed using the scientific notation. Okay, now let's take a look at constants. So I get rid of these two lines here, Control X, Control X. We define a constant with the const keyword. Const float p 3.14, and we have to put f at the end because it's a float. Now, because we declared p as a constant here, I cannot change it in my program. So I cannot go here and say p equals 1. The compiler is not happy, and that's why we see that red underline here. If you hover the mouse here, it says, read-only local constant cannot be used as an assignment target. It's a little weird expression to understand, but basically, the intention of using constants is to have some kind of safety in your program. So if there are values that should not be changed throughout your program, you define them as constants. And this way, you won't accidentally modify their values. Well, if you made it this far, you seem to be very enthusiastic about learning C#, and I highly recommend you to take my C# Basics course using the link in the video description. This way, you can learn all the core concepts in a structured way, and you don't have to waste time jumping from one free tutorial to another. You can see that currently this course has over 5,000 students with over 400 5-star reviews. Plus, it comes with a 30-day money-back guarantee. So if you're not satisfied, you can ask Udemy for a full refund within 30 days, and you get all your money back, no questions asked. Again, you can get this course using the link in the video description. I hope to see you in the course. In this video, I'm going to talk about various kinds of type conversion in C#. We have implicit type conversion, explicit type conversion, which is also called casting, and we also have conversion between non-compatible types. Here is an example of implicit type conversion. A byte, as you know, takes only 1 byte of memory, and an integer takes 4 bytes. So we can easily copy a byte to an integer. What happens at runtime is, let's take a look at this slide. So here's the binary representation of our b variable here. So 1 is represented as 7 bits of 0 and 1 bit of 1. When we copy a byte to an integer, what the runtime does is it prefixes that value with a bunch of zeros to fill the 4 bytes. So there is no data loss. In situations like that, when the compiler is 100% sure that the types are compatible and no data loss will happen, values can be converted to a different type implicitly. Here's another example of implicit type conversion. So we have an integer, set it to 1, and we copy that to a float. Again, in this example, no data loss will happen. But let's take a look at this one. Here we have declared an integer, and we're trying to copy that to a byte. An integer is 4 bytes. So when we convert that to a byte, 3 bytes out of 4 bytes will be gone. And there is a chance for data loss. Now, data loss doesn't always happen. It only happens if the value we stored in the integer is beyond the capacity of a byte. In this example, 1 can be stored in a byte, so no data loss will happen. But if we had, let's say, 300 here, we cannot store 300 in a byte. So as a result of that conversion, data will be lost. When the compiler knows that there is a chance for data loss, it doesn't allow implicit type conversion. And you need to explicitly tell the compiler that you're aware of the data loss and you still want to go ahead with the conversion. In situations like that, what we do is we prefix the variable with the target type. So here, I'm trying to convert I to a byte. This is what we call as casting. Here is another example. So we have a float set to 1.0. And if we try to convert that to an integer, the compiler would complain. I will show you that later in the coding demo. So we need to tell the compiler that we are aware of the data loss and we still want to convert f, which is a float, to an integer. So we cast it, like here. Sometimes we are working with types that are not compatible, but you still need to convert them. For example, we might have a number represented as a string, as you see here, and we need to convert it to an integer. In situations like that, because string and int are not compatible, we cannot use explicit casting. So we need a different mechanism for converting a string to a number. In situations like that, we need to use the convert class or use the parse method. So convert class is part of .NET Framework and is defined in the system namespace. It has a bunch of methods for converting various types to other types, and they all start with 2. In this case, we're trying to convert s, which is a string, to an int32. Int32, as you know, is a .NET Framework type which maps to a C# integer type. Remember, a byte is 1 byte, a short is 2 bytes, an integer is 4 bytes, and a long is 8 bytes. You probably know that each byte has 8 bits. So an integer which has 4 bytes times 8 bits ends up being 32 bits. That's why it's called 2int32. And int16, which represents 16 bits, equals to short, which is 2 bytes. We also have this parse method here. All the primitive types that I explained in the last lecture, like integer, long, float, boolean, they all have this parse method. And the parse method takes a string and tries to convert that to the target type, in this case an integer. Here are some of the methods that you can find in the convert class. To byte, which converts the given value to a byte. To int16, to convert the given value to a short. To int32, to convert the given value to an integer. And to int64, to convert the given value to a long. Okay, enough theory, let's jump into code and see all this concept in action. Okay, let's say implicit type conversion in action. First, I declare a byte, call it b, and set it to 1. Now I declare an integer and set it to b. Again, to recap, a byte is only 1 byte and an integer is 4 bytes. So we can copy b to I without data loss. And as you see, there is no compile time error here. Let's put I on the console. So console.writeLine. And we pass I here. Note that as I typed console.writeLine, my ReSharper plugin automatically added this using system statement on the top. Again, if you don't have ReSharper, you need to go manually add this statement here. We run the application by Control and F5. So we got I on the console. Now let's reverse this and see what happens. So I'm going to get rid of this code here. Control X, Control X, Control X. First, I declare an integer, set it to 1. Then I declare a byte and try to copy I to B. We immediately got this red underline here. If you hover the mouse here, the tooltip says cannot convert source type int to target type byte. Sometimes this error might be in a different file which is not open in Visual Studio here. So you may see the error when compiling the application. Let's simulate that. So I compile this application by Control, Shift, and B, which stands for build. So here's the error. Cannot implicitly convert type int to byte. An explicit conversion exists. Are you missing a cast? So now you understand the concept of implicit versus explicit type conversion. So what we need to do here is to do a cast. So we cast that integer to a byte. Now in this case, no data loss will happen because the value is small enough to be stored in 1 byte. Let's put B on the console. Console.writeLine, B. We run the application. So everything is good. But let's see what happens if we set I to, let's say, 1000. We cannot store the number 1000 in a byte. The maximum we can store in a byte is 255. So if we run the application now, we got 232 because some of the bits were lost. And this is the reason that C# compiler knows that there is a chance for data loss, and it enforces you to explicitly specify the cast. Sometimes you know that despite the differences in data types, there is no chance of data loss, like in the last example where I was set to 1. In those cases, you can safely apply a cast. Okay, now let's take a look at non-compatible types. So let's clean up this code. I start by declaring a string. Let's call it number and set it to 1, 2, 3, 4. Just recapping from the last lecture, note that here I could declare this with the var keyword. And C# compiler automatically detects that this is a string, so number will be defined as a string. And we can see that by hovering the mouse here, it says system.string. Now let's say we want to convert that to a number. If I declare an integer, like I cannot cast that number to an integer because they're not compatible. Let's take a look at the error. Cannot cast expression of type string to type int. So if you see that error, that's the time when you need to use the convert class. So we type in convert dot, take a look at these methods here. To byte, to char, to int16, to int32, and many other methods here. So let's convert that to an integer, which is int32, and pass number as an argument here. Now let's print out the I on the console. Run the application. So I is 1, 2, 3, 4, all good. But let's see what happens if instead I declare this as a byte. And here we need to use convert.toByte. And here we display B on the console. A byte does not have enough storage to store the value of 1234. So when we run the application now, the application crashed. We cancel this here. And here's the exception. Exception is .NET Framework's error reporting mechanism. It's an advanced topic and I have covered it in detail in my C# Advanced course. But in this video, I will briefly show you how to handle exceptions. So here it says on handle exception, the type of exception is system.overflow exception, which means we try to store a value that was too large or too small for a byte. So each exception or error has a type, in this case overflow exception, and has a message. Value was either too large or too small for an unsigned byte. Sometimes the exception messages are friendly enough that are easy to understand. Sometimes they're a little bit tricky, and the best way to work out what is going wrong is to jump on Google and search for the error, and there's pretty much always a Stack Overflow page that explains that. Now let's discard that. Let's see how to handle the exception here. So the exception happened during conversion of that string to byte. What we need to do here is to wrap these few statements with a try-catch block. Let's see how it works. So I just typed try and pressed enter, and Visual Studio automatically generated this block for me. Again, this is what we call a code snippet. Let me undo this and show you one more time. So try, see this try here in the IntelliSense, and this icon represents a code snippet. So if I press enter or tab, you automatically get this code block. So what I'm going to do now is to move this code into the try block, and the catch block gets an exception. By default, Visual Studio has this throw here. Don't worry about it, just delete it. Again, I will explain it in detail in my C# Advanced course. For now, let's see what's going on here. So the code that you put inside the try block will be somehow monitored, and if an exception happens, this block will be executed. This prevents your application from crashing. The reason our application crashed earlier was because we did not handle the exception. So if you don't handle the exception will be propagated to the .NET runtime. And .NET runtime's mechanism is to stop your application and display the error. Here we can handle the exception, and that would prevent the exception from being propagated to .NET runtime. So instead, we can display a friendly message to the user, saying, for example, console.writeLine. The number could not be converted to a byte. Now let's run the application again. See, we got the friendly message and the application didn't crash. So what I want you to take away from this lecture is this convert class works pretty well in most cases, but in cases where the source type cannot be converted to the target type, there is a chance for exception, and you need to be aware of that. And what you need to do is to wrap this block of code with try catch. Let's take a look at one more example before we finish this lecture. Let's remove this and instead define a string, call it str, and set it to true. We can use the convert class to convert that value to a boolean. So bool b equals convert dot to boolean, and we pass that str here. Again, in this example, string and bool are not compatible, and that's why we cannot use explicit casting. So here we are using the convert class. We can display b on the console. Let's run the application. So the true string was successfully converted to a boolean value. Okay, that's pretty much it for this lecture. Before I finish, I just need to emphasize something here, that throughout this course, during early lectures, you may see me using some short variable names like b or str here. That's purely for demonstration and keeping things simple. And in building real-world applications, we should really avoid naming our variables a, b, c, str. It's not really a good practice. The only exception is when we get to loops, which you will see later in this course. In for loops, we use counter variables and we call them I or j. It's a common convention. Now here we are just starting to learn C# and it's really impossible for me to demonstrate building a real-world application because we're just covering the basics or alphabets. I hope you enjoyed this lecture and thank you for watching. Okay, we got to operators. In C# we have 5 types of operators: arithmetic, comparison, assignment, logical, and bitwise. Let's take a closer look at each of these operators. We use arithmetic operators in computations where we're working with numbers. So as you see in this slide, we have add, subtract, multiply, divide, and remainder of division. We also have 2 arithmetic operators called increment and decrement, which are shortcuts for adding 1 or subtracting 1 from a variable. So a++ is equivalent to a equals a plus 1. Now with this increment and decrement operator, there are 2 ways you can apply them. You can use them as a postfix. So in this example, a is 1, and when we apply the postfix increment operator, first the value of a is assigned to b, so b is going to be 1, and then a is incremented by 1. So in this example, after the second line is executed, a is going to be 2, and b is going to be 1. Now let's take a look at a different way of applying increment operator as a prefix. So in this example, in the second line, first a is incremented by 1, and then it's assigned to b. So after the second line, both a and b are going to be 2. So be aware of this difference. Okay, next, comparison operators. So we got equal, which is indicated by double equal sign, not equal, greater than or equal to, less than, and less than or equal to. Now, what I want you to pay attention to in this list is that the testing for equality is accomplished by double equal sign. And that's different from a single equal, which is the assignment operator. Next, assignment operators. So the most commonly used is the one with a single equal sign. So here we set a to 1. Pretty basic. Now look at the next 4 types of assignment operators: addition assignment, subtraction assignment, multiplication assignment, and division assignment. Let's see how they work. For example, addition assignment. A plus equal 3 means add 3 to A. So it's equivalent to writing A equals A plus 3. And the same rule applies to other 4 assignment operators. Logical operators are used in Boolean expressions, which are often used in conditional statements. We'll get to conditional statements later in this course. So a real-world example is where you have a condition and you want to make sure that condition and another condition both are true, or maybe one of them is true. So that's where you use a logical operator. In C#, the logical AND is indicated by double ampersand, and the logical OR is implemented by double vertical line. We also have the NOT operator, which is indicated by an exclamation mark. And finally, here we've got the bitwise operators. Bitwise operators are often used in low-level programming, like when working with Windows API, or in sockets, or encryption. Explanation of these is beyond the scope of this course. But if you're interested, let me know and I write a blog post for you. Now, what I want you to take away here is that the bitwise AND is indicated by a single ampersand, whereas the logical AND, which we use in conditional statements, is indicated by double ampersand. Same for bitwise OR and logical OR. So remember the difference. Okay, enough theory. Let's flip over to Visual Studio and see all these concepts in action. Okay, let's start with the arithmetic operators first. So I define 2 variables, a equals 10, b equals 3. Let's add them together and display the results in the console. That's pretty easy, right? Run the application. So the result is 13. Now let's take a look at division. So I replace the add operator with division. The result is 3. The interesting thing here is because both a and b are integers, the result of the division ends up being an integer. If you like a floating point number as the result of the division, you need to cast both these numbers to a float. So, like this. Now if you run the application, the result is a floating point number. Now let's look at a more tricky example. Let's say C is 3, B is 2, and A is 1. I want to show you the concept of operator precedence. So if I type A plus B times C, what do you expect the result to be? From a mathematical perspective, B should be multiplied by C first, which means 2 times 3 equals 6, and then it should be added to 1, so the result should be 7. Let's run the application. So C# behaves exactly as what we expected. So multiply or division operators have higher precedence than add or subtract. If you like to change the precedence, you can do so by using parentheses. So in this case, if you would like to have A and B added together first and then multiplied by C, this is how we would achieve that. In this case, the result will be 9. There you go. Okay, now let's take a look at comparison operators. So let's get rid of C here and instead see if A is greater than B. Very simple example, right? The result is false. So what I want you to know here is the result of a comparison expression is always a Boolean value, which is true or false. We can test for equality. So double equal sign. In this case, A is not equal to B, so the result should be false. Now let's see the not equal operator. So simply have an exclamation mark here, followed by an equal sign. In this case, because A is not equal to B, the result should be true. Okay, now let me show you a more tricky example. What do you expect here? Well, first, this is the not operator, which is applied on Boolean values or Boolean expressions. In this case, this is a Boolean expression. And as you saw earlier, it was true because A is not equal to B. So we apply the not operator to that, and the result ends up being false. Let's run the application. So we got false here. But this code is not easy to understand or easy to read, because here we have two negatives. One negative and two negative. And for us humans, two negative is hard to comprehend. Two negatives always equal to one positive. So in your program, if you end up in situations where you have two negatives, make sure to always inverse them with one positive. So in that case, I can get rid of the first negative and convert the second negative to a positive like that, and we will get the same result, which is false. Now let's take a look at logical operators. So I create another variable here, var c equals 3. I'm going to change that to c greater than b and c greater than a. What do you expect here as the result? Well, c is greater than b, so the result of that expression is true. Also, c is greater than a, so the result of that expression is true as well. And here we have the AND operator. So true and true equals to true. Let's run the application. There you go. Now let's make a tiny change here. So this time, because we know c is not equal to a, this expression evaluates to false. True and false results in false. Let's run the application. So we got false. Now let's see the effect of the OR operator. So I'm going to replace the AND with OR, which is double vertical line. In this case, that is true or false. The result ends up being true. And of course, we can apply a NOT operator here, as you saw earlier, which changes the true to false. Now, this expression doesn't really look easy to understand. It's just purely for demonstration of how we can combine different operators and make up more complicated expressions. Okay, that's it for this lecture. I hope you enjoyed it, and thank you for watching. Okay, so we got to comments. A comment is text that we put in our code to improve its readability and maintainability. In C# we have two ways to write comments. If your comment is only a single line, you can prefix the comment with /. But if your comment is longer and it's multiple lines, you need to start it with /* and then finish it with */. This type of comment is more like the comments we used to write in C and C++ code. These days, it's more conventional to write either single line or multi-line comments prefixing with /. So in this example, we can rewrite this multi-line comment with // style like this. Now, as a rule of thumb, keep your comments to minimum. Use comments only when required, and that's when explaining whys, hows, constraints, and things like that. Do not explain what the code is doing. Your code should be so clean and straightforward that it doesn't need comment. If a comment explains just what the code is doing, it's redundant. And the problem with redundant comments is we change the code, but not everyone is very consistent in changing the comments. So after a while, these comments become outdated. And because they don't get compiled like the code, there is no way to validate them, and after a while, they become useless. So again, keep them to minimum and explain whys, hows, and constraints that you had at the time you wrote the code, so the next person who is reading your code knows the reason why you wrote the code that way.
In this section, you learned that C# is a statically typed language, which means once you declare a variable, you need to specify its type, and that type cannot change during the lifetime of that variable. You also learned about the primitive types in C#, such as integer, character, boolean, and so on. Now in the next section, I'm going to introduce you to non-primitive types in C#, such as classes, or structures, arrays, strings, and enums. So I will see you in the next section.